Hello, on this lesson we're going to be solving radical equations. We use something called the power rule in order to solve these equations, and the power rule says that we're going to raise both sides of the equation to the same power, and the power will depend on the type of root that we had. In this case, on this first example, we have the square root of 3x. The index is 2, so we're going to raise it to the second power. Now, when we solve these equations, we sometimes get what looks like a solution that actually is not, because it would be an extraneous solution. If we check it in our original equation, it doesn't give us a true statement, so we would have to discard that as a solution. So you just want to check on each of these as you solve. On this first equation, we're going to raise it to the second power. Remember, because it's a square root, so with an index of 2, we can remove the radical by squaring this. So that gives us 3x equals 9. Divide by 3 to solve. Our proposed solution is 3. Now, we want to go ahead and check that. All right, so in the original equation, we take 3 times 3. Right, we replace the x with 3. The square root of 9 equals 3, so you can see, yes, it does check. All right. On the second equation, it's also a square root, so it has an index of 2. So we will raise both sides to the second power. So x plus 1 equals 25. And we solve this simple equation by subtracting 1 on both sides. And then we check. And you can just check this, by looking. 24 plus 1 is 25. The square root of 25 equals 5. All right, so 24 plus 1. So yes, it checks. Okay, on the next equation, it's also a square root, but it's equal to a negative number. And so this actually means that we will have no solution in this case, because it's not possible to take the square root and get an answer that is negative 5. So just because of this, I can say no solution. Let's say that you didn't notice this. Also, we sometimes use the notation of the empty set. Let's say you didn't notice, okay? So say this. What if you went ahead and solved? So you take the square root of 5x equals negative 5 and square both sides. And it appears that you are going to get a solution. But when you check, you will see, no, it really is not a solution. So when I check, now if you didn't check on this one and you went ahead and said that your solution was 5, then you would miss this if you were doing your homework on my lab. So 5 times 5, and you guys can see the square root of 25 is not equal to negative 5, so it does not check. All right, so we go back to no solution. All right, so these are the steps for solving a radical equation. Step 1, isolate one radical on one side of the equation. So far, we have already had that done for us ahead of time, right? Raise each side of the equation to a power equal to the index. And so far, we've only done square roots, so we're taking them to the second power. If the equation still contains a radical term, repeat steps 1 and 2. And so actually for this class, we are not going to have any like that. And then check all proposed solutions in the original equation. So I've already shown you step 2 and step 4. Step 1 will be coming up as we work through these. So notice on this equation, it is not, the radical is not isolated. To isolate, we're just going to add 4 to both sides of the equation. So now we have the square root of 3x plus 3 equals 12. So now we can solve. And then we will take both sides to the second power. So 3x plus 3 equals 144. And then we subtract 3, divide by 3. We divide by 3 and we get that x is 47. So 47 is the number that we will check in our original equation. And remember, always go back to the original. So 3 times 47 plus 3 minus 4 equals 8. So that is 141 plus 3. The square root of 144 is 12. So you can see that it does check. All right, so this solution was x equals 47. And then we move on to the next one. Now this is the first one that we've had with a cube root. So whenever we're solving, we're going to take both sides to the third power, right? Because if we take it to the third power, that clears our radical. So 2x minus 6 equals 64. And solve for x. So add 6 to both sides, divide by 2, and x is 35. And of course you're going to check. So 2 times 35 minus 6 minus 4 equals 0. So 70 minus 6 is 64. The cube root of 64 is 4. So it checks. X equals 35 is a valid solution then. Okay. So next one, we're going to subtract the 2x. So we isolate the radical, and then we will square both sides because this is a square root. So negative 5x minus 1 equals 4x squared, right? Because we take negative 2x times negative 2x. Now this will be a factoring question, so we need to set it equal to 0 by adding the 5x and the 1 to the right side of the equation. I'm going to add the 5x and the 1, so we are, make that a plus, so that we have it set equal to 0 and our leading coefficient is 1. Now this one factors. You could use grouping here if you needed to. It's going to be 4x plus 1 and x plus 1, right? Because the only factors of 1 are 1 and 1, so that makes it pretty simple to get the 5x that we needed for our middle term. And then we set both of these equal to 0. Maybe I'll do that down here. All right, so 4x plus 1 equals 0, or x plus 1 equals 0. So my two possible solutions will be negative 1/4 and negative 1. Now you actually have to check both solutions to be sure that this is going to, that they're both actual solutions. So we have negative 5 times negative 1/4 minus 1. Plus 2 times negative 1/4 equals 0. Sorry about the barking dogs. Okay, so we have 5/4, right? When I multiply that, minus 1, which would be minus 4/4, and that is the square root of 1/4, minus, that's 2 over negative 2/4, or negative 1/2. And the square root of 1/4 is 1/2, so this one does check. And then we'll check the second one. I never did write check up here. So the square root of negative 5 times negative 1 minus 1 plus 2 times negative 1 equals 0. So we have 5 minus 1, which is 4, minus 2, and you can see that that also does check. So our two solutions are negative 1/4 and negative 1. Let's see, I'm checking to see how many more I have. Okay. So I believe that we can go ahead and make it through this entire question. We'll see. Now, this one gets a little trickier because we're going to square both sides to solve. And when we square 3 minus x, remember that means 3 minus x times 3 minus x. So we have 2x minus 3 equals 9. That's going to be a negative 6x plus x squared. You can always go over to the side and multiply this out. Right? Go through that process, and then you'll see where all this came from. Okay, so I'm going to subtract the 2x and add the 3 so that I have this on one side in descending order for factoring purposes. I subtract the 2x from the negative 6x, so that's negative 8x. I'm going to add 3 to 9, so that makes 12. All right, so we're going to find factors of 12 that have a sum of negative 8. Right, so factors of 12 that have a sum of negative 8 are going to be negative 2 and negative 6, right? Because when I add those, I get the negative 8. So x minus 2 times x minus 6, set both equal to 0, and solve. So my possibilities are 2 and 6. And then of course I have to check these solutions, these possible solutions. So 2 times 2 minus 3 equals 3 minus 2. So 4 minus 3 is 1. The square root of 1 equals 1. That does check. And then I will check the 6. So 2 times 6 minus 3 equals 3 minus 6. You can see on the right side I'm going to get a negative number, right? That's going to be equal to negative 3. So this one's not going to check. 12 minus 3 is 9. The square root of 9 equals negative 3 is false, right? So 6 does not check, and that means x equals 2. We have to throw out the 6 because it does not check. All right, so I'll stop this video and finish this lesson on the next video.